this video we will see the roots of equation. So in this video we will see the bisection method. So first we will see the introduction. Consider an quadratic equation f of x is equals to ax square plus bx plus c. So root of this equation, we know the x is equals to minus b plus minus root b square minus 4ac divided by 2a. So in general this is the quadratic equation root. So methods to find the roots of equation. To obtain an appropriate solution is to plot the function and determine where it crosses the x-axis. This point which represent the x value for which f of x is equals to 0 is the root, where the x-axis is crosses this function, then it is a root of the equation. Another is the trial and error. This method involves the process of initially guessing a value for x and accessing whether f of x equals to 0. When it doesn't, a new estimation is made and f of x is reevaluated. This iterative process continues until a satisfactory value of x is found, where f of x equals to 0. Now we'll see the methods to find the roots of equation. First is bracketing method and second one is the open-end method. In bracketing method, two methods are there, bisection method and false position method. And in open-end method, Newton-Raphson method, second method and Brent's method. So out of these methods, first we will see the bisection method in this video. So bracketing method, as the name implies, these are based on two initial guesses that bracket the root, that is are on either side of the root. So consider a x-axis, y-axis. Okay, y is here denote f of x. Consider a curve which is crosses the x-axis, and on that x-axis root is lies. So in bracketing method, consider two initial guesses randomly, x1 and x2. Then root is lies between this interval x1 and x2. This is a general bracketing method. Now we'll see the bisection method. So for that, consider x-axis, y-axis, and consider one curve which is crosses the x-axis. Then on x-axis root is lies. Consider two initial guesses, x1 and x2. So steps to solve the problem. First, select initial guesses, that is x1 and x2. Then put x1 and x2 in given function. Then third one, check for the function either it is a negative value or positive value. If f of x1 is equals to negative and f of x2 is equals to positive, or f of x1 positive and f of x2 negative, vice versa, that is opposite side, then consider that interval for calculation. Then calculate the new root. New root is how to find, taking the average of these two initial guesses, x1 plus x2 divided by 2. Then next step is, after that put new root in the given function and find the value. If it is negative, then replace the negative value from the initial guesses, and if positive, then replace the positive value from the initial guesses. And finally repeat this step number 4 and 5 as mentioned in the problem. So this concept, bisection method concept, is one another condition will be there. This is a summation, a function f of x and f of x2. Okay, multiplication of these should be less than 0. If x1, you can say we can see here the x1 is in negative value and x2 is in positive value. So we can conclude this is a condition, that is f of x1 into f of x2 less than 0. So this concept, bisection method, we'll see with the help of numerical. Determine the roots of equation f of x is equals to minus 0.5 x square plus 2.5x plus 4.5 using the bisection method up to the 3 iterations with initial guesses of x1 is equals to 5 and xu is equals to 10. Here in the numerical function is given and the clearly mentioned 3 iterations. Up to the 3 iterations means after third iteration your root will be finalized. And initial guesses are given. Initial guesses x1 is 5 and xu means within a 5 and 10 there is a 2 initial guesses will be lies. Then solution. First step is select 2 initial guesses. Function is given. Then this first initial guess is 5 and this next initial guess is 10. So your 2 initial guesses is lies between the 5 and 10. So first 5 is put in the function. So f of 5 is equals to minus 0.5 x1 square plus 2.5 x1 plus 4.5. So put this value 5 and we'll get the value of 4.5 which is positive. Okay, after simplify this, so this is a positive value. Then check for the next initial guess, that is x is equals to 6. So put this value in the given function. So f of 6 is equals to 0.5 into 6 square plus 2.5 into 6 plus 4.5. After simplify this, we will get the value of f of 6 is equals to 1.5 which is also positive. If the f of 5 and f of 6 both are positive, then check for the next guess, because we have the or we want the two opposite sign values. Then satisfy the condition f of x1 into f of x2 should be less than 0. So check for next f of 7. Okay, next initial guess and put in the given function. So 0.5 minus 0.5 into 7 square plus 2.5 into 7 plus 4.5. So f of 7 is equals to minus 2.5 which is negative value. Then here we can conclude here the f of 6 is equals to 1.5 is greater than 0 and f of 7 is minus 2.5 is less than 0. Then root is lies between the 6 and 7. Satisfy this condition, f of x1 into f of x2 should be less than 0. Then here first interval is 6, 7. F of 6 value is positive and f of 7 value is negative. That's why I written there the plus and minus sign. So then go for the first iteration. First iteration is find the root of the first equation, first root. Here f of 6 is equals to 1.5 greater than 0 and f of 7 is minus 2.5 which is less than 0. Now root is lies between the 6 and 7. Then take the average of this. 6 plus 7 divided by 2 is equals to 6.5. Okay, this is the first root of the equation x1. Then check for the function value. Function f of 6.5 is equals to minus 0.5 into 6.5 square plus 2.5 into 6.5 plus 4.5. After simplification, we will get the value of minus 0.375 which is negative value. Then go for the second iteration. Here function f of 6 is equals to 1.5 which is greater than 0 and f of 6.5 is equals to minus 0.375 which is less than 0. So this is the opposite sign. So replace this with the first interval, that is 6, 7. So 6 is positive value and 7 is negative value. So negative value is replaced with the negative value. So f of 6.5 is replaced with the 7. Now root is lies between the 6 and 6.5. So no new interval is 6, 6.5 which is opposite sign, that is plus and minus. Then take the root of the equation. Then 6 plus 6.5 divided by 2 is equals to 6.25. Then check for the function value. F of 6.25 is equals to minus 0.5 into 6.25 square plus 2.5 into 6.25 plus 4.5 is equals to 0.5938, which is positive value. Then go for the third iteration. So third iteration is here f of 6.25 is 0.5938, which is greater than 0, and f of 6.5 is minus 0.375, which is less than 0. So now root is lies between the 6.25 and 6.5. Interval is 6.25 comma 6.5, opposite sign. If negative, then replace by the negative. If positive, then replace by the positive. Then root of the equation is x3 is 6.25 plus 6.5 divided by 2 is equals to 6.375. Then after third iteration is your final root. In numerical clearly mentioned, do up to the 3 iterations. So root of the equation is 6.375. So in this way we can calculate the bisection, any root of the